We report on results from an activity that was implemented with pre-service teachers enrolled in a math content course for elementary teachers. The Four Corners activity incorporates concrete manipulatives and figural representations to build on students' understandings of concepts related to additive reasoning as a foundation for multiplicative reasoning. We argue that this activity, the Four Corners activity, aligns with AMTE's standards for preparing teachers of mathematics, as it sparked meaningful conversations in our classrooms that really deepened our pre-service teachers' understandings of mathematics for teaching. Now, our goal was to provide our pre-service teachers with an opportunity to re-experience additive reasoning concepts from the perspective of their future students. And so one of the things that we did with that goal in mind was introduce our students to a different number system. And this is the quaternary number system, also known as base 4. In this base system, the only digits that are used to represent numbers are 0, 1, 2, and 3. And so here you can see a chart that one of our students made counting up in this system. And so we spent some time with our pre-service teachers engaging them with this number system before we implemented this Four Corners activity. So for the Four Corners activity, essentially what we did was we presented teachers with just a blank grid, and you can see here just a blank piece of paper with some counters. Now we had red chips, and on the flip side we had yellow chips. We didn't intend for the red and yellow to mean anything, but students actually did use those colors quite creatively as they were solving these problems. But essentially what students did, their objective was to represent 4 different addends for a problem in the 4 corners of the page. So what do I mean by that? Well, we gave them examples like this. So this is an example in base 4 where we had 1, 3 plus 2 plus 1, 1 plus 2. So there's your 4 addends, and we tell them which corners to place those chips in. So you're supposed to place 1, 3 chips in the top left corner. And so if you look at these two students, student A placed 1, 3 chips in the top left corner here, while student B did the same thing over here. They could situate these chips however they'd like, and for some students this became strategic. And we just had them situate the chips, and then their goal was to find the total of the 4 addends however they'd like. And we encouraged them to, at first, with group members, do this physically with manipulatives and actually talk about their strategies. We then gave them a website where they could do this online and start creating some really cool figurative representations where they could include their annotations. And so we have some examples of student work here where you can kind of see some of the really interesting mathematics that's taking place with our pre-service teachers. To kind of give you an idea of some of the concepts that came up, go ahead and take a look at these 2 examples, student A and student B. And so the annotations in these 2 work samples really do highlight some important concepts related to additive reasoning. For example, if you look at student A, they grouped the 2nd addend and the 4th addend, so these 2 on the right, while student B started by grouping the 1st addend and the 2nd addend. And so in both, the students arrived at the same answer. They both got an answer of 1, 0, 0, which is the correct answer. But it shows that the changing of groupings, depending on what you add first, it does not affect the sum. And so we talk about the associative property. Also, by adding in the 2nd and the 4th addends first, such as 2 plus 2, student A demonstrated that changing the order of addends does not change the sum. And so we have a really great conversation about the commutative property of addition as well. So during the class discussion, we use student work samples like this to distinguish between associative and commutative properties, and this led our class to formulate more abstract representations where we actually were using variables to represent the commutative and associative properties. It can be difficult for students to make connections between concrete and abstract representations for concepts such as these properties. And so this activity was intended to give students experiences with both concrete and figural representations to help them make connections and help make these connections more explicit. And so the Four Corners activity provided a productive way for our teachers to see concepts related to additive reasoning from the perspective of their students. So we talked about key concepts like subitizing, being able to recognize the number of objects without actually counting them. And for this particular activity in base 4, situating 4 or 1, 0 counters together in a square pattern ended up being very productive. And so you can see that like a lot of students started situating 4 chips and calling that 1 0, and they were able to do that without actually counting them. And so we have interesting conversations about subitizing. We also talked about cardinality, and so being able to know that the last number counted is the number of objects in a set. And like I said earlier, we talked about associative properties and commutative properties of addition. And so in summary, we believe that this activity was productive for our students for a few different reasons. One, it gave them experience with concrete, figural, and abstract manipulatives. It was more interactive than we had intended, and so during the concrete part of this activity, students were really collaborating and talking about moving sliders and using different strategies. And like I mentioned earlier, some people were even using colors as they were putting together these solutions. And what was really nice towards the end of our conversation, because we gave them access to virtual manipulatives, and they were able to actually annotate their 4 corners solutions, students were able to kind of compare and contrast different solutions and basically come to the realization that when it comes to additive reasoning, there's really so much more than just adding numbers a specific way. And so it was a really great activity for our pre-service teachers.